Went up to Singapore. It was a mobile laser scanning project, the 5,500 kilometres worth of roadways, 3 rounds of airborne mapping, being able to have that model there and be able to look at it, inspect it, take measurements at any time that you want is a very valuable tool. Environmental modelling, visualisation and analysis, solar energy potential and development planning. That's what I want. Go and give that for me. That's going to make it easier for them to procure and it's going to make it easier for us to deliver.
Daniel Kruimel, Sales Manager, Asia Pacific at Woolpert. In addition to being a licensed surveyor, he is also a Level 2 Certified Professional Hydrographic Surveyor. So ladies and gentlemen, please welcome Daniel Kruimel and Digital Twins in the Southern Hemisphere.
Thank you, everyone. It's great to be here. Not sure about the white stuff falling from the sky. That's a little bit foreign to me, but didn't quite pack for it, but I'm surviving and luckily it's warm in here. Now, I have to confess something. There is a problem with my presentation, and hopefully some of you might pick it up on the next slide. In looking through this, you can see that the case studies that I'm going to talk about today, there's a couple of asterisks, and for anyone that is very geographically minded in the room, which is probably a lot of you, you'll probably pick up that 2 of those aren't actually in the Southern Hemisphere. I can guarantee you that I come from Australia, so I do live and work in the Southern Hemisphere, but after submitting this abstract and then going and having a look at the projects that we've been involved with in the last few years, the Singapore project and the Louvre Abu Dhabi project were just too good to leave out. So they are indeed in the Northern Hemisphere, but please forgive me for that. In addition to that, I'm just going to talk a little bit today, begin with why Woolpert is involved with digital twins, and then round out with some closing thoughts and go where to next. Now, what is a digital twin? That's been covered enough already, so I'm really not going to go into it. The panel that I was on earlier today, that sort of opened up with that, asking what a digital twin was. And look, I think broadly we can sort of say at the moment, there's not a concrete definition. It means different things to different people. So really what I'm going to focus on today is talking about some of the projects that we've been on and what they've managed to achieve. So why is Woolpert involved in the digital twin space? Now, this word cloud, which sort of sums up a lot of the geospatial capabilities that Woolpert has, when you start looking at some of the definitions or some of the things that come under the digital twin umbrella, a lot of them tick off on here. So that's the sort of framework that I'm going to take in talking about the case studies. I'm going to talk about the particular ingredients. I do like cooking, so I use that as my little bit of a quiche way of doing it. So I'm going to talk about the ingredients of the projects or the digital twins that we've been working on, what they actually do, give some snapshots of that, and then I've also for each one looked at a before and after. So how has a particular business process been done before the digital twin had been implemented, and then how has it been improved? So the first one is going to be talking about Singapore. Now, really the role that Woolpert has played in Singapore is we've been mapping the country. Now, I sort of say country, Singapore is quite small for those who don't know. I'll have to look up a US equivalent. I grew up in a place called Adelaide in Australia, and there's an island off the coast of Adelaide called Kangaroo Island. That island is 6 times larger than Singapore. So Singapore's only 718 square kilometres. I apologise for not putting that into miles, then coming up with a US equivalent. I'll do that for next time. But I can, this is probably the topic that I can bore you to death over for hours because I lived in Singapore for 4 years doing these projects. We've done 3 rounds of airborne mapping in Singapore now, which in theory it should be easy because it's such a small area. But there's plenty of reasons as to why it's not as easy as it could be. And then also a ground-based project. So I actually went up to Singapore. It was a mobile laser scanning project to do the 5,500 kilometres worth of roadways from it. So as I said, if you corner me in the exhibition hall later, I can literally talk for hours on this one. So the national 3D map that we've been working with the Singapore government on, the ingredients, at least on the projects that Woolpert's worked on. So mobile laser scanner point clouds, and you'll see there's a picture later of the Regal VMX 450 that we had on that. So that project started back in about 2015. So that was sort of the leading edge scanner at the time. Now we've got city GML models. The Singapore government certainly went down the open source. They didn't want to get locked into a vendor. So all of the 3D models that we've delivered, we have done some vendor-specific formats as well, but it's been in city GML 2.0. And that's building models, transportation models, and city furniture models. And given the crowd, I thought we'd talk about some of the technology and software involved. So that was processed for the city GML building models using PLW Enverse. So that's out of PLW based here in the US. They came over and helped us with the project. And then Topodot for the mobile laser scanning data. The aerial LiDAR and imagery data that we've collected was 10 points a square metre. For the aerial imagery, it was mostly 7.5 centimetre nadir and oblique. When I say mostly 7.5 centimetre, there were some different flying heights, which we sort of had to take what we could get. But generally, that was what we were aiming for. And the most recent round that we did, so we've done surveys in 2014, 2019, and 2024. So the one in 2024 last year, we used a Leica CityMapper 2 sensor, which has a combined imagery and LiDAR sensor all in the one unit. And then from that, we produced DTM and DSM products. So what does the Singapore National 3D Map do? So some of the use cases I'm going to show here are environmental modelling, visualisation and analysis, solar energy potential, and development planning. But ultimately, what our involvement here is we collect the data for the government. The government does not release it to the public. They give it to other government agencies. So if we had the data, I'm sure we'd be able to come up with some other ways to use it as well, but we're not given that privilege. So solar potential analysis, I think there was a topic that came up before of how do you get some of the low-hanging fruit, or how do you get those early wins to help to justify what you've done. And this was certainly a pretty straight off the bat one. So the solar potential analysis, I think that was conducted from the first survey in 2014. And certainly when we've been modelling the buildings from the survey 1 year ago, there's a heck of a lot more solar panels. So it looks like they identified plenty of places to put them from the initial one. Urban mobility is another big one in Singapore that they've really used not only the aerial data but then the ground-based data to look at. So Singapore's really focused on walkability and accessibility. So construction of new overhead walkways over the expressways to keep pedestrians off the road. And then they've also constructed a lot of covered walkways as well, because generally in Singapore it's 1 degree north of the equator, and if you're outside walking, you're either going to be hit by the sunshine or you're going to be hit by rain. So either one, having some shelter overhead is generally quite nice. So the Housing and Development Board, they've got a project that they've done where they've started to look at some environmental modelling. So there's a snapshot there of throwing in all the buildings and then starting to add in all the trees and vegetation to start looking at thermal comfort. And then they've also done some other applications like traffic noise, wind flow, etc., etc. So my before and after snapshot, I always keep an eye out on LinkedIn, because that's quite often where I'll see some of the use cases get promoted. And this is a really, I say cool, unfortunately it has a bit of a bad mentality because it does involve traffic accidents, but it's still a good before and after snapshot. So after a traffic incident, what would happen is someone would go out with a scanner to capture the scene, and they'll need to manually scan the site. So the downsides for this would require quick response. So whenever the accident happens, someone's got to get out there and scan it straight away. And there can be some safety concerns as well. And probably at the point in time that there's been an accident, someone wanting to go out there and use a scanner, that's not the most important thing at that moment in time. And one other limitation, the scan would generally be limited to the area of the crash. So if you wanted to get further surrounding context, that would probably be difficult to do. How's it being done now? Basically, a 3D replica of the accident site is created from, I've said the digital twin, but it's basically the mobile laser scanning point clouds. They then use that to simulate and recreate the events that led up to the accident. So it's safer and it's faster to use the data that's already there. A broader area can be included, and then the resultant output is a report that gets prepared for use in court. So here's a snapshot of what this looks like. There's an article on that's available on the Straits Times website that shows this, but it sort of gives you a general idea. So the bottom left there is the vehicle that was driven around Singapore to capture all the MLS data. I've set that vehicle up and did plenty of time in it myself, so know it quite well, and it's quite close to my heart. And for me, a lot of time and effort went into collecting that data, so I'm pretty happy when I see it get used effectively. Probably key lessons learned from the Singapore project. It's probably more of just an observation than a lesson learned, but yeah, it's been really amazing to see. They started off with a vision. They didn't know exactly how all this data was going to get used, but they just kind of knew that if you had this foundational spatial data set, there would be some good applications that would come out of it. Okay, the second one, this one is in the Southern Hemisphere, so we're sort of back on track now before I then skew off with the Louvre Museum in Abu Dhabi, but this is the port of Mackay in Queensland. So the ingredients that we had here, so terrestrial laser scanner point clouds, that was captured using a Leica RTC 360, so that had associated imagery as well. We then ran some UAV LiDAR and imagery, the predominantly imagery to try and basically create some reality mesh models with obviously higher resolution imagery. We did create some reality mesh models over the whole site for with some 7.5 centimetre Vexel Osprey imagery, so that's just an oblique and nadir imaging camera. There's some vessel-based bathymetric data, so sonar collected. And then, as I mentioned, 3D reality mesh modelled from 2 different sorts of inputs. And there was an LOD 300 BIM IFC model. And then this was all presented back to the client. In addition to sort of your more conventional deliveries, it was also been hosted in a SaaS web-based viewer, which is Point Terror. So what's it being used for, or what's it doing at the moment? Probably the first one is virtual condition and asset inspection. There's some cool examples of simulations for berthing that it's been used, and then also development planning as well. So when I showed this to a conference for some port hydrographic surveyors, they looked at this and said, it was a bit gimmicky showing this in 3D. But one of the good use stories that came out of it was some of the people in the port, they had previously, when they were looking at these kind of scenarios, they were doing it on a bit of paper with like a model ship, and that's how they were looking at how the ship would sit. So for them, this was just mind-blowing to be able to actually visually see the ship in the surrounding context. So asset inspection, what we've got here is some reality meshes that were made from capturing imagery underneath the wharf, so quite a difficult area to get to, particularly so Mackay has quite a high tide range, so there'll be times when you just can't physically get under there based on the tide or the prevailing weather conditions. So being able to have that model there and be able to look at it, inspect it, take measurements at any time that you want is actually a very valuable tool. Another good before and after. So from an asset inspection or trying to take some of these measurements, what used to happen, so the client here, North Queensland Bulk Ports, they've actually got 4 ports spread throughout the state, and they've got offices in quite a few locations. So they would have people that would need to come from the Brisbane office to Mackay. That's a 1.5 hour flight one way, plus all the other to and from the airport and waiting at the airport in between. Mentioned before of sometimes needing to schedule based on when the tides would be so that you could go and do the inspection. Now it's 5 minutes to log into the SaaS viewer, and they're looking at a single sign-in option, which might make it even quicker. So one of the other topics that came up before in the panel was who pays for these projects. When we presented with the client on this, the asset manager at North Queensland Bulk Ports effectively said within a couple of months the project had paid for itself just in the cost savings of not having people travelling to and from. So that was a pretty easy win. The key lesson learned on this one, so if you go back to the story before of the people that had been using the model ship on a bit of paper, involved more stakeholders. So the more each person in the organisation that was then shown the data once it was loaded into the viewer, everyone came up with their own use cases of how they could use the data in the platform to benefit what they needed to do in the business. The next one is we're doing a project for Schools Infrastructure New South Wales. So this is under the Department of Education. And in effect, this is using digital twin technology to help them with their end goal. Is they want to build 100 preschools at existing school sites throughout the state. And what they want to do is basically take some reality capture data and have it all in a viewer, so they can visualise where they're going to build these new preschools. It's kind of a fun one that it came from a minister making a promise to build 100 schools, and then everyone's had to quickly scramble around and figure out how they can do that in the time frame, and had to look at technology to innovate. So in addition to building a viewer for them, so you can see some of the ingredients there, Esri ArcGIS Enterprise, some custom Esri JavaScript, Oracle Asset Management and Azure Data Lake. We've actually done some surveys of the school as well. We've done terrestrial laser scanner point clouds, and then some associated survey drawings, and then 3D reality meshes as well. So what's it do, and I should also mention this is an active project at the moment, so there's still things coming out. But it's already enabled virtual inspection and simulations. Another key one is spatial display of operational data, so being able to take some of the asset and operational data and put it in a spatial 3D context. Obviously mentioned development planning before, and it's been designed in mind with the full asset life cycle from strategy and planning to development and operations once the facilities are built. So just a quick look. This is sort of more the GIS background. The image that we had before was the 3D viewer. But one of the key lessons that we learned on this project, and this came from early on, was the procurement model. Now, initially, we were sort of looking at a fairly fixed scope and fixed fee contract, and it became pretty clear as we were talking in the early stages that for what the client wanted to do and be able to have an agile approach to add or change things, or if they sort of wanted to create some additional functionality, that we needed to have the right contract in place to allow that agile methodology and approach. So the last one is the Louvre Museum in Abu Dhabi. So since opening in 2017, the Louvre Abu Dhabi has become the largest and most visited art museum on the Arabian Peninsula. And basically what they wanted to do was consolidate all known information of the facility to form the basis of an asset information model. And this would then future-proof the ongoing facilities management of the site. The starting point of this was Woolpert was engaged to provide survey, 3D modelling and then QR asset validation of the whole site, informed through the recycling of existing design models and drawings to maintain element metadata that would otherwise populate the future proposed facilities management database and management system. And in case you can't tell, I wasn't as involved in this project, which is why I'm reading on notes. It's not like the Singapore one where I can talk off my head, so apologies that I don't know this one as well as the others. The fieldworks on site consisted of terrestrial laser scanning utilising a Leica RTC 360 again, and also the Navis VLX2 backpack solution. This covered the entire site of 200,000 square metres and then explored all accessible cavities as well. Data was coordinated to the local UTM coordinate system and then processed in Autodesk recap format for feature extraction into Autodesk Revit. Maintaining the existing design asset library and reconfiguring as necessary to the captured data and proposed standards, the resultant product was very ambitious, but we ended up getting there, LOD 500 verified as-built of the full site, which is now currently under integration into a bespoke asset management system and viewer developed specifically for the museum. Some images here of the project. The top left shows a wireframe model of the entire facility. The top right and the bottom left, that shows some example of point clouds collected by the Navis VLX2. And then at the bottom right, we've got a cross-section of the building showing foundation piling as well as combined architectural, structural and MEP building elements. The before and after approach, so as mentioned, the site spans over 200,000 square metres. This was actually put together by one of my colleagues in Australia who's from the UK originally, and you can see that he was smart enough to actually put in the conversions between square metres and square feet, and then also Celsius and Fahrenheit as well, so he's one-upped me on that. Previously there was over 11,000 drawings and 110 component design models of mixed format and coordination, and it still didn't actually, and even with all of that, it didn't provide a comprehensive record of the entire site. And there was a disconnected and incomplete asset database. So what do they have now? Now they're able to do a desktop exercise to review the facility for any purpose, which is certainly beneficial in saving having to walk about in 40-degree heat. They've got a consolidated single source of truth, accurately coordinated with real-world positioning, and scheduled parameters of asset-tagged elements linked to database and maintenance manuals. Some lessons learned on this project. Asset tagging and database records require buy-in and cooperation from all internal stakeholders to ensure successful functional documentation and avoid repeated and or missing data. A fully developed digital twin is the long-term goal, with the options of how to get there is currently under exploration. That's, I think, been another theme that we've seen throughout the sessions, that getting to that full-fledged digital twin, you've got to make a start. It's sort of hard to maybe get there all in one heap, but a staged approach can sometimes be the best way to get there. And probably one of the other lessons that we learnt on this one was just the environmental considerations for survey equipment. Operating equipment in 40-degree heat and fairly extreme temperatures. Most of the equipment gets manufactured and tested in areas not quite as harsh as that. So having backup equipment in case of failure in those conditions proved to be pretty important. So where to next? Look, this is just a few of my thoughts, and look, I acknowledge I'm a surveyor, so I'm sure there's people that have from other backgrounds that some of this stuff would be basic for them already. But one thing that I would say is patience. When I sort of see arguments over what a digital twin is, or hey, you're doing this and it's not a digital twin. If that for someone is, they had to call it a digital twin to get some funding and that's their first step of the journey, like that's okay. Everyone will be at different stages and some are going to be more than advanced than others. But if we're all starting to move in the same direction and go down this digital journey, I think in the long run, that's going to be a good thing. Something that I think will really help to adopt this as well is to simplify. So come up with some streamlined offerings for common accounts and markets. There's so many different technologies out there that sometimes it can be difficult to figure out what you need. The case of the port one that we've got, if that can be streamlined so that any port just goes, that's what I want, go and give that for me, that's going to make it easier for them to procure and it's going to make it easier for us to deliver. So integration, moving, and this is one that I'm sure others are already doing, moving beyond just geospatial. I mean, that's sort of how a lot of these start with reality capture. It's a geospatial minded, but then integrating real-time sensor data, engineering information, etc. That's how you really start to unlock the value. And then we've also seen automation. So that was featured in the first presentation. They were actually talking about automation from a data capture perspective, but there's also using other tools. Obviously, AI is going to come into it to automate the analysis and the decision-making using digital twins. So I made just a little comment there of, you climb to the top of the ladder by starting on the bottom rung. So to get to the top rung of having a fully integrated and working digital twin, you're not going to get there in one leap. You've got to start somewhere. So that's all.